The failure of the Iran hostage rescue mission in 1980 demonstrated to the United States military a need for a new type of aircraft that could not only take off and land vertically but also could carry combat troops, and do so at speed. The U.S. Department of Defense began the Joint Service Vertical Takeoff Landing Experimental (JVX) aircraft program in 1981, under U.S. Army leadership. The defining mission of the U.S. Marine Corps, USMC, has been to perform an amphibious landing. The service quickly became interested in the JVX program. Recognizing that a concentrated force was vulnerable to a single nuclear weapon, airborne solutions with good speed and range allowed for rapid dispersal, and their CH-46s were wearing out. Without replacement, the USMC and the Army margin was a lingering threat, akin to President Truman's proposal following World War II. The OSD and Navy administration opposed the tiltrotor project, but congressional pressure proved persuasive. The Navy and USMC were given the lead in 1983. The JVX combined requirements from the USMC, USAF, Army and Navy. A request for proposals, RFP, was issued in December 1982 for preliminary design work. Interest was expressed by Aerospatiale, Bell Helicopter, Boeing Vertol, Grumman, Lockheed, and Westland. Contractors were encouraged to form teams. Bell partnered with Boeing Vertol to submit a proposal for an enlarged version of the Bell 1515 prototype on February 17, 1983. Being the only proposal received, a preliminary design contract was awarded on April 26, 1983. The JVX aircraft was designated V-22 Osprey on January 15, 1985. By that March, the first 6 prototypes were being produced, and Boeing Vertol was expanded to handle the workload. Work was split evenly between Bell and Boeing. Bell Helicopter manufactures and integrates the wing, nacelles, rotors, drive system, tail surfaces, and up ramp, as well as integrates the Rolls-Royce engines and performs final assembly. Boeing Helicopters manufactures and integrates the fuselage, cockpit, avionics, and flight controls. The USMC variant received the MV-22 designation and the USAF variant received CV-22. This was reversed from normal procedure to prevent USMC Ospreys from having a conflicting designation with aircraft carriers, CV. Full-scale development began in 1986. On May 3, 1986, Bell Boeing was awarded a $1.714 billion contract for the V-22 by the U.S. Navy. At this point, all 4 U.S. military services had acquisition plans for the MV-22. The first V-22 was publicly rolled out in May 1988. The project soon suffered several blows. That year, the U.S. Army left the program, citing a need to focus its budget on more immediate aviation programs. In 1989, the V-22 survived 2 separate Senate votes that could have resulted in cancellation. Despite the Senate's decision, the Department of Defense instructed the Navy not to spend more money on the V-22. When the projected development budget greatly increased in 1988, Defense Secretary Dick Cheney tried to defund it from 1989 to 1992 in order to cancel it. He was overruled by Congress, which provided unrequested program funding. Multiple studies of alternatives found the V-22 provided more capability and effectiveness with similar operating costs. The Clinton administration was supportive of the V-22, helping it attain funding. The first of 6 prototypes first flew on March 19, 1989 in the helicopter mode, and on September 14, 1989 in fixed-wing mode. The 3rd and 4th prototypes successfully completed the first sea trials on USS Wasp in December 1990. The fourth and fifth prototypes crashed in 1991 to 92. From October 1992 to April 1993, the V-22 was redesigned to reduce empty weight, simplify manufacture, and reduce build costs. It was designated V-22B. Flights resumed in June 1993 after safety changes were made to the prototypes. Bell Boeing received a contract for the Engineering Manufacturing Development phase. The prototypes were also modified to resemble the V-22B standard. At this stage, testing focused on flight envelope expansion, measuring flight loads, and supporting the MV design. Flight testing with the early V-22s continued into 1997. Flight testing of 4 full-scale development V-22s began at the Naval Air Warfare Test Center, Naval Air Station Patuxent River, Maryland. The first flight took place on February 5, 1997. Testing soon fell behind schedule. The first of 4 low-rate initial production aircraft, ordered on April 28, 1997, was delivered on May 27, 1999. The second sea trials were completed on board USS Saipan in January 1999. During external load testing in April 1999, a V-22 transported the lightweight M777 howitzer. In 2000, there were 2 further fatal crashes, killing a total of 23 Marines, and the V-22 was again grounded while the crash's causes were investigated and various parts were redesigned. In June 2005, the V-22 completed its final operational evaluation, including long-range deployments, high-altitude, desert and shipboard operations. Problems previously identified have reportedly been resolved. U.S. Naval Air Systems Command worked on software upgrades to increase the maximum speed from 250 knots, 460 kilometers per hour, 290 miles per hour, to 270 knots, 500 kilometers per hour, 310 miles per hour. Increase helicopter mode altitude limit from 10,000 feet, 3,000 m, to 12,000 feet, 3,700 m, or 14,000 feet, 4,300 m. By 2012, changes had been made to the hardware, software, and procedures in response to hydraulic fires in the nacelles, vortex ring state control issues, and opposed landings reliability has improved accordingly. An MV-22 landed and refueled on board limits in an evaluation in October 2012 and 2013. Cargo handling trials occurred on Harry S. Truman in October 2015. NAVAIR tested rolling landings and takeoffs on the carrier, preparing for carrier on-board delivery. Development was protracted and controversial, partly due to large cost increases, some of which are caused by a requirement to full wing and rotors to fit aboard ships. The development budget was first set at $2.5 billion in 1986, increasing to a projected $30 billion in 1988. By 2008, $27 billion had been spent and another $27.2 billion was required for planned production numbers. Between 2008 and 2011, the V-22's estimated lifetime cost grew by 61%, mostly for maintenance and support. It's the V-22's production costs are considerably greater than for helicopters with equivalent capability. Specifically, about twice as great as for the CH-53E, which has a greater payload and an ability to carry heavy equipment the V-22 cannot. An Osprey unit would cost around $60 million to produce, and $35 million for the helicopter equivalent. Lieutenant Colonel Odin Lieberman, commander of the V-22 squadron at Marine Corps Air Station New River, was relieved of duty after allegations that he instructed his unit to falsify maintenance records to make it appear more reliable. 3 officers were implicated for their roles in the falsification scandal. In October 2007, a Time magazine article condemned the V-22 as unsafe, overpriced, and inadequate. The USMC responded that the article's data was partly dated, obsolete, inaccurate, and held expectations too high for any new field of aircraft. 60. In 2011, The controversial defense industry-supported Lexington Institute reported that the average mishap rate per flight hour over the past 10 years was the lowest of any USMC rotorcraft, approximately half of the average fleet accident rate. In 2011, Wired magazine reported that the safety record had excluded ground incidents. By 2012, the USMC reported fleet-wide readiness rate had risen to 68%. However, the DoD's Inspector General later found 167 of 200 reports had improperly recorded information. Captain Richard Walsh blamed errors on incompetence, saying that they were not malicious or deliberate. The required mission-capable rate was 82%, but the average was 53% from June 2007 to May 2010. In 2010, Naval Air Systems Command aimed for an 85% reliability rate by 2018. From 2009 to 2014, while cost per flight hour had dropped 20% to $9,520 through a rigorous maintenance improvement program that focused on diagnosing problems before failures occur. As of 2015, although the V-22 requires more maintenance and has lower availability, 62% than traditional helicopters, it also has a lower incidence rate. The average cost per flight hour is $9,156, whereas the Sikorsky CH-53E Super Stallion cost about $20,000 per flight hour in 2007. V-22 ownership cost was $83,000 per hour in 2013, while technically capable of auto-rotation if both engines fail in helicopter mode, a safe landing is difficult. In 2005, a director of the Pentagon's testing office stated that a loss of power while hovering below 1,600 feet, 490 m, emergency landings are not likely to be survivable. V-22 pilot Captain Justin Moon McKinney stated that, "We can turn it into a plane and glide it down, just like a C-130. A complete loss of power requires both engines to fail, as one engine can power both propellers via interconnected drive shafts." Though Vortex Ring State, VRS, contributed to a deadly V-22 accident, flight testing found it to be less susceptible to VRS than conventional helicopters. A GAO report stated that the V-22 is less forgiving than conventional helicopters during VRS. Several test flights to explore VRS characteristics were canceled. The USMC trains pilots in the recognition of and recovery from VRS, and has instituted operational envelope limits and